talking about the power of microservices in mobile application development today. My name is Caroline Murphy, and I am in product marketing here at Convey, and we are going to be presented to you today by Jiku Venkat, who's our VP of Product at Convey. And with that, well, actually, first of all, I'd like to ask everyone to, if you have questions during the webinar, there's a question box in your GoToWebinar tab. And please feel free to enter your questions in there. And after the webinar is concluded, we'll open up for questions. And I'll ask your questions to Jiku, as many as we can get to before we're out of time. So with that, I'm going to hand it over to Jiku.
Thank you, Caroline. Again, my name is Jiku Venkat. I'm VP of Product here at Convey. Thank you all for taking the time to attend today. And as Caroline mentioned, we'll be talking about microservices and why they are important in mobile application development. To kick things off here, we've all heard the word microservice or microservices being bandied about quite a bit. There is a lot of literature around that describe microservices. So I thought it'd be good to start off with just what it is. And we put this definition together based on a lot of sources of people blogging, talking about microservices, and our own experience using and developing with microservices. So basically, microservices is an architectural style or an architectural pattern for software architecture, where a single application is actually a suite of very small services, and the key word here is very small services. Each of these services could be running in its own process, although that's not really a strict definition. You could have a single small service that is actually composed of multiple processes. People sometimes stretch that part of the definition, but that's okay. And also communicating, all of the communication happens with very lightweight communication mechanisms and very lightweight protocols, often a very RESTful interface. And we'll contrast this with other architectural styles and architectural patterns that this has evolved from, just so we have a good contrast of what we're talking about here. And these services usually embody some business capability combined with something that from a software engineering perspective can be broken down to a logical component that can be developed and deployed and scaled and managed independently. And typically microservices are deployable in a completely automated way. The build, integration, test, deploy cycle is typically a very modern one, embracing a very modern DevOps paradigm. And specifically, the deployment is completely automated. It's also scaled and managed in an automated way, and typically runs in some type of container as its runtime. So that's what a microservice is. Fairly, loose definition. It's not very, very rigid, but it is distinct from other software styles, and we'll talk about that here in just a second, by looking at how microservices evolved, right? So we are used to very large monolithic applications from the old days, whether that you can go hark back all the way to the mainframe days or to the client server days, and even the web world. And there were large monolithic applications that basically embodied a large amount of business logic or application logic in a single software component. So you made any change to any part of the component, you had to deploy the entire component, whether that was your WAR file in the web, in a 3-tier web architecture, where all your business logic was embodied in a Java component, and you deploy that. That was a very monolithic piece. Or in the old days, you had the server component of a client-server application, very similar, very monolithic type approach. We evolved from that to more a service-oriented architecture. Still fairly large services, not very tiny, but we started to build services and composed applications with these services. These services still fairly large. The communication mechanisms were still fairly heavyweight. For example, whether that was SOAP, XML, or RPC in the synchronous world, or with SOA, you also had asynchronous communications using a message broker or an enterprise service bus or some other sub mechanism like that. The SOA architecture was still fairly large services with very heavyweight communication mechanisms and not necessarily deployable in any automated way. From there, we evolved to more microservices, which are essentially breaking down your SOA or your services into smaller and smaller components. Each can be individually scaled, individually managed. So you want to make a change and deploy one service, you only impacted that one service. You didn't impact the entire application. And these services communicated with each other and with other components using very, very lightweight protocols. And there were a large number of these, obviously, as this picture indicates. So this lends itself to better efficiencies because these can be individually scaled. So for example, if you had something that is fetching location information from a data source, and the number of times you make that request is independent of something else that is fetching data from another database, and the frequency of those requests are lower, the entire service doesn't have to scale based on the one that makes the most number of requests, right? So you could scale these services that make a lot of requests independent of ones that make less frequent requests. And so you got a lot of efficiency, which is what we indicate here on the x-axis. And also from a deployment model, you made one change to one component and you could just deploy that component, right? So you could operate in a very agile software development lifecycle. Whereas and you could also develop the software. Each microservice would be owned by one or more developers, and they could work in a fairly autonomous fashion and deploy their components independently and have well-defined interfaces, lightweight interfaces to communicate. So this is to give you a little bit of the contrast of where we came from and how this evolved, so you also understand what microservices are relative to what you've been used to in the past. Next, we'll start to get into why are microservices important, especially in this world of mobile-first application development, where you're developing applications primarily for use in mobile devices or tablets and hybrid environments. Why are microservices important? Several reasons for this, and by no means is this a comprehensive list, but we wanted to give you an idea of at least the primary reasons why microservices are important. Number one is data access, right? So you need, there is no easy way with a service-oriented architecture to bring together data from many different data sources, whether they be enterprise data sources within your company, as well as cloud-based data sources like for location information or weather information, maps, things like that, and make these available in a secure way, in a compliant way, reusable way, be able to scale these independently, and so on. Because the number of services that you're going to need in a mobile-first world is much, much larger than what you're used to in the web world, and we'll give you some examples of that here. Data transformations, right? Being able to, based on the data being available from these different sources, combining that with context of what the user is doing, where they are, what type of device they are, and being able to do that orchestration of the data, including filtering it, marshalling the data, federating it, um, doing federation composition of this data. This is all what gets you to have a first-class or a 5-star user experience with your mobile app. Because the mobile app, essentially, from a screen perspective, is going to be populated with data from multiple different sources, and contextually, you have to do the right thing for that user experience. The other thing is, if you tightly couple the front-end client side of the mobile application with the back-end, this adds to development time. Why? Because if you tightly couple this and your front-end is making calls to these different back-end data sources, any changes you need, you're going to have to request this of the back-end data service, and that's going to take time, and it's going to slow down development. Also, any changes made on the back-end side are going to impact the front-end application and going to necessitate and require changes to the front-end applications, and again, increase dev time, lots and lots of complexity. So looking at this in a very pictorial way, right? So you have the enterprise databases or data sources here on the right side. Typically, you have to do some type of authentication, whether that's an enterprise authentication or social authentication, and you have multiple enterprise data sources, right? And in a monolithic application architecture, what you're doing is you're making hard-coded connections or connections to these various data sources, data services from the client app, and so the client app is very aware, and there is no abstraction between the client app and these backend data sources, and that leads to all of these challenges and problems that we just talked about. And this works well in the web world, right? Because the web applications send all the info to the client, and the user or the application on the client side then has to decide how this information is displayed, viewed, and how the information is passed to these various services in the back end. So here's an example of what is typically called a web portal, and it has different tabs that represent access to perhaps different databases or data sources here to retrieve different types of information. And so you can clearly see how the front end is very, very aware of the back end, and from a user experience standpoint, you've not abstracted any of this, and the user is also very aware through these tabs that these are all coming from different data sources, and the user decides which tab to go to and what information they want to look at, whether they want to look at quotes or sales revenue analysis, or look at a dashboard or anything else. These are typically calls that are made to different data sources. So that's the a typical web application. Now, if you look at a typical mobile-first application or a similar application that would be designed with the mobile-first view in mind and provide a true contextual mobile experience, the data from all these different sources are actually composed and presented to the user in a form that's meaningful to the task at hand, or what is the user trying to do, what is that workflow, what is that user story, and how can I present that information to fulfill that user story or the task that is being performed. And that's how you want to present this information. And I'm sure you're all aware. I mean, I use apps on my mobile device all the time, and I use a similar app that's available on the web. And I frequently find for well-defined mobile apps, I am gravitating towards using the mobile app because it's a lot cleaner, it's a better user experience, help me get what I want to do done, rather than going to the website and being inundated with a lot of information, moving across different tabs and having to do see a lot more information than I have to. Here it's a very clean format. I can come in here, I can look at the location information, which is obviously coming from a location service, and I can see the weather, which is really for that location, which is coming from the weather service, and I'm composing that that information. I can see the traffic where I'm at right now, some of the history. Um, I can look at places that are close by to the location I'm at. All of this is what is represented to me in the user experience when I'm looking at this app. And really, this is what we call context, right? Where if you really want to build a true mobile-first experience, you need to bring together data that are relevant to the task at hand. And this is data that comes from the device itself, in the IoT world, from devices and from sensors. It's information like who you are, what your preferences are, what device are you on, where are you, your location, the network state you're on. Are you on Wi-Fi? Are you on a 4G LTE network? Because I might do things differently based on the network. The current status of the device is what is the battery level? Is it plugged in? Things like that, and being able to get that contextual information and use that contextual information in a relevant way to accomplish the task at hand. Getting data from other sources, like we just showed you, map information or social activity feeds, access to your social profile, and being able to integrate that into your application user experience, combining that with the systems of record, which are the enterprise data sources, right? The status of an order, purchasing history, there might be CRM systems that I'm connecting to internally to the enterprise, so I can get customer information and their preferences and tie that into these other sources of information, and external SaaS systems that the enterprise is using. I'm looking at a purchase order or a purchase requisition. I have to approve this purchase requisition. And by the way, this purchase requisition has information that is tied to it that will help me do the task, which is approve it or reject it. I'm able to view information, and this information might be available in other enterprise SaaS systems. For example, there are files associated with this purchase requisition that are stored in my SharePoint repository or in my Box repository, or there's some information when I'm in front of this customer to understand what they bought recently from my Salesforce data. Look at their credit history with me before I make them an offer. Things like that I have readily available to the task at hand. And this is really a true mobile-first user experience, right? This context. And we'll talk now about how microservices enables you easily to get to this context. So in order for you to be able to do all this integration and really present a very effective mobile-first user experience, your front-end team and back-end team have to collaborate across all these paths here that you see represented in dashed lines, right? You have to collaborate with many different back-end teams that are responsible for all these services, and ensure that you're delivering data to the client application, first delivering the right data, delivering it in a manner in which is easily consumable by the front-end client application. And these front-end client applications evolve very rapidly, so your back-end team also has to evolve at that pace so that they can, the front-end application team put something out there, it's not quite what they want, and they want to change an endpoint on a service, and they have to make that request, and the backend team has to react very quickly. So you're interacting with backend teams that are responsible, for example, third-party services like push, location, and what we call engagement services, analytics, enterprise data sources, enterprise authentication, social integrations. Also, you may want to do backend business logic, right? And this backend business logic are things you want to do with the data that is specific to this mobile application. What in the old web world we'd put in the application server layer. You might want to do some of this application logic in the back end, and so you have to create a service or an environment for you to be able to write that code and deploy it and manage it and so on. So, and then you have to do this over and over again across multiple apps and across multiple device platforms on the front end side, because remember, you have to run on an Apple device, you have to run on a Android device, you have to run on a Windows tablet, and there's just lots of different devices and platforms that you have to adapt to, and then do it over and over again across multiple applications. So moving on, how do you get this done, right? How do you get this done and also be able to transform this data and compose this data in a meaningful way for this application? You have to have something in place, right? That's the big red box here. Otherwise, you're doing a lot of work over and over again in the client application. It's absolutely not what you want. And so we see a lot of people, and here's a real example of a customer support application running on a PaaS platform. And what you do is you get access to a PaaS platform. In this specific case, it's a Node.js PaaS platform. And once you have the PaaS platform, this is a platform as a service platform built on using Node.js, which does the routing for you of these calls that you're making from the front-end application to the appropriate services in the back end. And then you build all your services, and these might be microservices within Node, Node modules that you're building to facilitate, for example, logging in to an enterprise authentication source. You're building another service that does the data transformation, so you're presenting a mobile-friendly API back to the client application. You're building a service to do the logic in Node to do the analytics piece, being able to fetch data, usage data from the mobile app, create a database to store it, and then retrieve it and make that available, building a service around that, building a service around enabling push for your mobile application, right? So that you're interacting with an Apple push notification service or the Google push notification service, GCM, to enable push for your devices. So you're writing all of these services, writing any business logic you need to do the composition of these services. And pretty much you're creating these microservices. Now you have to monitor them, you have to manage them, you have to scale them. Yes, you have a PaaS environment that helps you with all that, but you still are responsible for developing the code, maintaining the code, testing the code, integrating the code, and doing all the integration with these external data sources on the other side. There's lots of complexity here. It's still tightly coupled. Remember, you're tying this all through the mobile API. There's not really true abstraction here, right? With this type of approach, and we see a lot of people doing this, and they spend a lot of time, use a lot of people. It takes a lot of effort to build something like this, and to also do this so that it's reusable is even more effort, right? You're essentially creating a platform, right? Doing this, right? That is very generic, that you can use across multiple applications. But what if you had most of this, if not all of this, pre-built and ready for you to use on day one? And by the way, if you still don't like these pre-built services available that are available pre-built ready for you to use, and you want to take these microservices, customize them, or build your own small microservice to do something specific that meets your needs, yes, you want to be able to do that as well. But what if all that was available for you, that you don't have to go build it yourself, and it was available to you in the form of a platform, right? And it had the abstraction in a client-side library that is available across native platforms, across hybrid platforms. So the client code is completely abstracted from all of this backend transformation, composition, and access to multiple data sources, all of these things that you're doing, and you're truly able to decouple the front end from the back end. So you're enabling two-speed IT, which is the front end can proceed at a speed that is different from the back end, and that's okay. So you have, when I say pre-built microservices, you have microservices that are already built in that do things like push notification, give you access to location information, completely abstracted. All you have to do in the client application, say, I need access to this information, you have it in the form of a data collection, for example. You want analytics information, either in the front end or in the back end. Again, you have it available in the form of an abstracted data collection. And social integration information. And you have the ability to have pre-built hooks that allow you to transform data on a request or in the response. All of this available to you. Plus, you have all of the integration to standard enterprise authentication sources or data sources already built in. So the same application that we just reviewed that you did with the Notepad now gets, I'll come to that in a second here, but gets transformed where it's now using all these pre-built services. To drill down a little bit, from the back end, you have IT providing these microservices or services in a service catalog that the front-end teams can then consume readily using a client-side library, and instead of building it themselves, right? Instead of developing all this themselves. So you have links to enterprise authentication sources combined with social authentication sources, in an authentication, a set of authentication microservices available in a catalog that you can choose from. You have user engagement services like push. So from a front-end development standpoint, you're simply consuming all this and not actually building or developing all of these microservices and doing all this federation, data access, composition, all of these things. They're all built in for you. So you can now, from a front-end standpoint, focus on the user experience and not have to worry about the fact that my purchase requisition is coming from SAP. The documents associated with this purchase requisition are coming from SharePoint or Box or whatever. I don't have to worry about that. I simply deal with collections, and there's these backend services that I can simply consume that make all this data, these collections available to me, right? And available to me efficiently in a very performant way, and scale as the needs of my application scales, that all of this can scale. And I have analytics information available to me also in collections that I can use to understand usage information, performance information, and be able to visualize all this, right? And combine that with all the content. Go ahead.
Hey, Jiku, just to, someone had a question, if we could just point out where the microservices are in this diagram, for clarity's sake.
Absolutely. So the microservices that are in this red box in the center, really what we show as the microservices layer here in the center is what we are talking about, where there are pre-built services. And as I show you in the headline here, there is actually a service catalog that you have access to these microservices, and then you can build your own and make that part of the service catalog as well. And there are some pre-built microservices that allow you to do things like federation, composition of data, transformation of data that are pre-built that you can use. Okay. So the same app now, migrated to a platform like Kinway, which had the pre-built microservices and the ability to do your own custom microservices. Starts with actually using a well-abstracted client library that completely abstracts the backend. That's really the primary purpose of the client library. And it has features like offline caching. So some of these data collections you're getting can be cached, and the caching is all handled from the backend. in terms of what get cached, and so there are microservices that are responsible for managing that cache, all the user management, push notification, all that is encapsulated in this client-side library. And from a back-end perspective, you have an authentication service that does the user authentication, the user management. There is a server-side library as well that allows you, if you want to write your own microservices, there is an SDK and a library that allows you to write your own microservices, plus provide you pre-built transformations that you see here. For example, I am fetching the purchase requisition data. I'm going to stay on that example here. And there's 50 fields within a purchase requisition. I'm on a small phone, and I don't want to show everything, right? So I only want to show 10 of those 50 fields that I have available in a purchase requisition. There are pre-built transformations that I can simply hook into that allow me to filter the fields without having to write any code. These are pre-built services. I'm just basically going to a graphical user interface and clicking to get some of these transformation and filtration capabilities. And again, there is a push service that enables you to do the push notification for your app, and then pre-built integrations to your ERP system or your knowledge bases, your Salesforce CRM, other things, in a secure way that you can connect inside your firewall as well as third-party services outside your firewall. And all of this in orange here in the center is available as a service, which means we are responsible for we as in Kinvey are responsible for the complete life cycle management of this environment, right? Enabling you to, we are responsible for scaling it, managing it, providing an SLA and uptime guarantee for you as the consumer of this, so that your apps get the right data at the right time. So everything is completely managed in the platform. And if you really want to go write your own microservices, write your own integrations, you can leverage the Node PaaS layer that is shown here in the box and write your own Node modules. So you not only have the pre-built services, but you can also, for the more advanced user, go create your own microservices. All these microservices are running in independent containers that we manage, we scale for you. So you don't have to go shopping around for a PaaS environment and have a DevOps team. You leverage the power of our DevOps team that is working across multiple customers, and there is an economy of scale type of paradigm here where you are leveraging and taking advantage of the experience we have working with multiple customers by providing this service for them, right? So you're not having to learn all this on your own. So the benefit here is a better user experience, obviously. The focus is on providing that right user experience. So if we drill down here on the user experience and the user making a request, for example, I mean, the user actually trying to access in the app, trying to access some data, the client library, will initially make an authentication request to make sure the user is authenticated and has authorization to access that data that they are requesting, make the request on behalf of that user, and while making that request, you're also providing contextual information, not just who the user is, but where they are, what type of device they are they on their personal device, are they on a corporate device, all this is part of this context that you see in the center, right? So all that is available to you to hook into. So you can, on the request, you can transform that request with these pre-built hooks that we have before it gets routed out to the actual data source, whether that data source is inside your firewall or it's a Kinvey data store, which we also have, or a Kinvey file store, or a SaaS application in the cloud. and we get the response back again very securely. And you can do transformations on the response, again, based on having this context information that showed in dashed lines here available to you on that server-side library. You can take the response, you can filter data, you can compose data, you can federate the information so that if you're accessing multiple data sources and you only want to keep the metadata about these data sources internally, you can do that. And that's all pre-built, available to you, all the transformation, and finally deliver the data in a way that is easily consumable on the client side in the application. And really, one of the things we want to highlight here is this idea of context, right? And having this contextual information available through the SDK. So when you're making the request to the backend, I know who's making the request. That's readily available to me in my backend logic if I want to write something on my own microservice or leverage one of the pre-built services. What device? That device information is also passed. The location information, any preferences that can be passed via the application, history of past actions, so I can, do the right predictive thing, knowing what the past actions were, time zone, time of day, lots of these types of things, right, that make up the context that is now available. Think about, how you have to build all this yourself. You end up taking a pass and, building a lot of these microservices yourself. And not only that, going back to the previous slide, you would be responsible for the lifecycle management of this, the SLA of this, keeping these microservices up and running, scaling them, managing them, doing all that, right? And this is all provided to you. So again, you can focus on that 5-star user experience. Sorry, I already did that. So the other benefit of using this type of approach is obviously that you can now move to a more agile software development process, right? The old apps, you had a very waterfall approach of, designing, developing, building, deploying, and launching your app, and then repeating the cycle. It's a very, very waterfall approach. What the microservices and having an well-abstracted platform with two-speed IT enables you to do is to do a more iterative approach, right? So, for example, you can, because you're completely decoupled from the backend services, you can simply start writing your mobile application and maybe dummy up some data for the initial mock-up for your minimum viable product that you can release out there, or put out there to a small subset of users to say, hey, it's starting to make sense. I'm just mocking up data using this microservices layer that's available with Kinway, and also a data store and an auth source that is already pre-built available for me. I can simply start building the app and building a minimum viable product that I can put out there, test with a handful of users or stakeholders, iterate, right? And simply at some point, I can flip the switch where I say, well, I got this very well abstracted on the client end in terms of the data and the collections I'm using and the features and the contextual information I'm building into it, that I simply flip the switch on the back end to say, now the same data is being delivered to me from the data source and combined with the same context information. And I can iterate through this process of getting to the right application and the right user experience, but I'm using a very iterative process where at each step in the process I'm getting some user feedback, making some tweaks, doing some upgrades to the back end each time, and developing new business ideas, and but every time, very quickly I have deliverables to show. So instead of a 9-month waterfall software development lifecycle, I might do 4, 5, 9 releases over the course of those 9 months very, very quickly, and I'm getting constant feedback. Ultimately, getting to a better end product, right? And that's what this allows you to do. And we have shown this. I mean, I'm working with a customer as we speak where we are taking the same approach, right? Where we are building the front end using just mocked up data, knowing fully well that this data is eventually going to come from a SharePoint or from a Salesforce or from something else, but quickly showing something on the client side and then flipping the switch to get the file from SharePoint and the data from Salesforce or something like that. So the bottom line of all this, right, using microservices in a mobile-first application, the power of microservices, the bottom line, the value proposition here is the ability for you to go to market faster with a much better application, a much better end product, right? And you can do this several different ways, right? You can do it yourself, obviously, where you have to build everything, you have to deploy everything, you have to manage it, you have to make sure the SLAs are being met, and you have a whole team of people doing all of that. You can leverage a as-a-service PaaS environment, a platform, where you build your own microservices, like I said, for push notifications, for context, for these transformations, for this federation. You build all of this stuff yourself. You build the microservices. So you need a team of developers that can build this, test this, maintain it on an ongoing basis. That's what we call the DIY, do-it-yourself plus PaaS approach. You can do a similar thing with API management, which is more focused on the back-end data sources and making the right data available in the right way. But that's all they do is you get that API layer solved, but you still have to do the transformation, the composition, the context, and you have to build all those microservices either in a PaaS environment or in your own platform environment. Or you can use an MBaaS platform like ours, which has these pre-built microservices, but yet gives you the power to create your own and get started right away, right? And move much, much faster. And that's really the bottom line, is being able to start now, get to a minimum viable product as ASAP. And we have several real-world examples to show that you take half as much time doing it this way, and ultimately results in a much better user experience. So that's the end of the presentation, and I think at this point we are open for questions. Caroline?
Yeah, so we've got a bunch of good questions here. So I'm going to start right in with, if I wanted to develop my own microservices, where would I go and how would I do that?
So if you would want to develop your own microservices, you have two options, right? So you can go, if you want to do it within your premise on your own infrastructure, you can go create a virtualized environment or a container environment, typically using Docker or some tool like that. Get your IT infrastructure folks involved, get the hardware rack stack cabled, and then install the software, have your hardware ready and the system software ready, and then you basically need your entire IT infrastructure team to support you through that process of getting all the infrastructure set up and monitored and managed for you, and then you can start to do the development, and you would do the development. Alternatively, you could go to a PaaS vendor and have them leverage their microservices layer and then build all your services on top of that that PaaS layer. So it would be the DIY plus PaaS approach that we talk about here.
Okay, great. Next question that I've got, actually there's a kind of a question that's a follow-on to that, which is where specifically on the Convey documentation can they go to get started?
That's a great question. So if you go to devcenter.kinvey.com, there are guides, tutorial, and references, and you start with the guides, and you can get started right there, and that'll walk you through this entire flow that I showed you here in the slide, where you can do this entire flow. You can see how you get authenticated, what kind of transformations, compositions are available, what type of context information is available, how you route to different data sources, and get the response back to your app. So there's a getting started section that will walk you through the entire process, and you can pick the platform you want to get started on, whether that's iOS or Android or something else. We support several different platforms.
Another question, MBAS platforms already have some of the services like push, transformations, et cetera. So how is that any different now? And is this what we're calling microservices, or is that something different?
Essentially, what we are trying to show here is that a lot of the services that an MBAS platform provides to you are essentially inside the MBAS platform microservices, right? So it's essentially the same. And we also give you the power to create your own now. If you want the full customization and you want to create your own microservices, we give you the power to do that, or use our pre-built microservices.
So another question we've got is, are there any downsides of using microservices?
Yeah, so there's been some debate, although this train has pretty much left the station. People are adopting microservices, and there are real-world examples of big social media companies that have been very, very successful with microservices. But there are some downsides that you need to be careful of, right? That you need to guard against. This is not a new concept. It's been done before. It came from the Unix world, really, where we had all these daemons running that were essentially microservices. But you want to be careful that you don't have way too many of them, that it now becomes just a nightmare to manage and scale and operate this thing, right? So you just want, there's a good balance here of where you draw the line on. This needs to be separated out into microservices. There are a lot of good articles on the web on how you really enforce this pattern, and what are some of the parameters or guidelines you can use, basically based around business capabilities and your software engineering. This is something from a software standpoint is a logical component that I want to break into a microservice, and it makes sense to do, and it's a separate capability, and it's going to have different requirements on it in terms of access patterns and frequency and so on, that I want to be able to scale it independent of other services. So those are good guidelines to use, but again, you want to guard against not having zillions of things, that it becomes a problem to manage.
So Jiku, another question we've got here is it possible to document and share the details of a custom microservice that I built with my app developers? So similar to how API management solutions provide documentation on their capabilities. I'll let you speak to that.
Sure. So if you're building a microservice specifically to address the needs of a client app, yeah, the microservice would have an API that the mobile app could potentially talk to, but really that's what we are trying to abstract with the client-side libraries, so that the mobile app doesn't necessarily talk API, but the mobile app is talking in terms of data abstraction and data that they want to consume, and the actual API that is being used and the endpoint that corresponds to that API is abstracted away from that client-side developer. But sure, I mean, all these microservices do have endpoints that can be exposed.
Perfect, and we'll make this our last question, and if there's anything that anyone hasn't gotten fully answered, please feel free to reach out to us at webinars@convey.com. And our last question is, how do microservices address the scalability of back-end services?
Sure. So microservices, because they are individual services, and they are very small services doing a very specific task, they can be scaled independent of other microservices or other services, right? And so they run in their own containers, and based on the traffic that that particular microservice sees, then the CPU, memory, or network storage requirements of that service are scaled independent of others. So there's some efficiency you gain by doing that. versus having to scale a bigger service or a monolithic component. So you get a lot of efficiencies in terms of how much infrastructure you need to consume to perform a certain task.
Great. Well, thank you so much, Jiku. If anyone else had, there's a couple other questions that we didn't have time to get to, but again, please feel free to reach out to us at webinars@kinvey.com, and we'll make sure that we get those questions answered for you. And I just want to thank Jiku very much for this excellent presentation. Thank you.
Thank you.
All right, thanks everybody, and we'll see you next time.